Why is it essential to understand the properties of fluids? What makes their study so integral to our daily lives, from the water we drink to the air we breathe? These questions open the door to the fascinating world of fluid properties. Firstly, consider density. Simply put, density is the mass of a fluid squeezed into a unit volume. It's like a party. A packed party with many guests in a small room indicates high density. Denser fluids carry more weight per unit volume. Next, think about viscosity. This property measures a fluid's resistance to flow, akin to the internal friction within the fluid. Imagine trying to stir honey versus water. Honey's higher viscosity makes it harder to stir. Now, let's turn to pressure. Picture pressure as the force exerted by a fluid per unit area. It's like the constant push you feel when you're deep underwater. This force is crucial in understanding how fluids behave when contained or under different forces. Temperature too plays a vital role. It influences the density and viscosity of a fluid. Just like how a warm day can make a chocolate bar melt, changes in temperature can alter a fluid's properties. Next in line is compressibility. This property tells us how much a fluid's volume can shrink under pressure. Gases, for instance, are typically more compressible than liquids. Surface tension is another fascinating property. It's the force acting at the surface of a liquid, striving to minimize its surface area. This property is why droplets form and why capillary action occurs. Then we have buoyancy, the upward force on an object immersed in a fluid. It's the reason why some objects float while others sink, all based on the density difference between the object and the fluid. In a resting fluid, pressure increases with depth, a concept known as fluid pressure variation. This principle, described by Pascal's law, is vital in understanding hydrostatic pressure in fluids. We also need to consider velocity and flow patterns. Fluids can flow at varying speeds and in different patterns. Recognizing these flow characteristics is crucial in fluid dynamics and engineering. Lastly, there's the Reynolds number, a dimensionless figure used to predict a fluid's flow regime. This number is key in determining whether the flow is smooth, known as laminar, or chaotic, referred to as turbulent. In conclusion, these properties of fluids are the foundation for engineers and scientists when dealing with fluid mechanics. Whether designing pipelines, exploring aerodynamics, developing hydraulic systems, or understanding any application involving the behavior of liquids and gases, a comprehensive understanding of fluid properties is crucial. So, the next time you sip your coffee or watch the rain fall, remember, there's a world of fluid properties at work.